The economic impact of the state's water is estimated to be in the tens of billions. Cargo shipping, Ohio ports rank number 8 in the nation. Fishing, $3 billion in economic impact. Boating, $3.5 billion in economic impact. Tourism, $40 billion in visitor spending, plus 415,000 jobs, $892 million in taxes. What are the biggest threats to Ohio's healthy water? While many factors can threaten a healthy water source, the prevailing factor receiving the most attention in Ohio is pollutants, particularly phosphorus. When considering pollutants that can threaten Ohio's water, there are generally two categories: pollution from point sources like pipes from factories, ships, ditches, or water sewage treatment plants, and pollution from non-point sources like runoff from fields, urban runoff from streets and lawns, or sediment from construction sites. The amounts of dissolved phosphorus entering our water resources have doubled in the last 25 years.
My name is Paul Herringshaw, and I farm in southern Wood County, southwest Wood County. And so there was that big push in the 80s and early 90s to adapt no-till. And a lot of us have done it because they now have developed equipment can handle it. I didn't have to work this field in the fall, did not have to work it again in the spring before we planted it. And so it has been something that's been widely adapted. But what has been interesting is that the quality of the water in Lake Erie about 20-25 years ago was pretty good. And then it started going back the other direction. And what has been puzzling to us in agriculture is that actually it is well documented that our use of phosphorus fertilizer has been going down in that same time frame. So more and more farmers are adapting the GPS technology where we're using the variable rate, applying the area of the field that is needed.
The negative effects of HABs are felt on land and water alike. For the past few years, the impact of HABs have gained national attention in the wake of the water crisis in Toledo, Ohio, and a growing number of other Ohio cities that have been affected by contaminated drinking water that has become undrinkable due to the extremely high levels of microcystin. Perhaps the most promising research currently being conducted is through the use of prairie grasses and plants, including specific wildflowers, which are biological sinks.
So how do you see the grand design being of incorporating these nutrient-attracting, soil-retaining prairies in with the modern farm, so that farmer can be productive?
Good question. This is brand new. It's never been seen or tried in Ohio. Iowa State has done it. We know that it works. And here's the answer with a capital A. Let's imagine a producer has a big 500-acre field. And next to that field is a ditch into which all the rainwater runs. At the edge of that ditch, between the ditch and the field, we plant a strip of this tall grass prairie, of several grasses and 5 or 10, the fancy word is forbs, those are wildflowers. A real for sure diverse mixture of prairie plants. How wide should that strip be? It may be only 20 feet, it may be required to be 40 feet. We don't know until we trial it, but here's the point. Iowa State discovered this. As the rainwater runs across the field and has to filter through all of these prairie grasses here, two things happen. Above ground, these prairie grasses slow the water and cause the silt, the soil, to settle down. We dramatically reduce the erosion. Instead of the farmer's topsoil heading into the ditch, it's retained into these prairie edge, field edge strips. But crucially and most importantly, just below ground, all of those microorganisms, the fungi, the bacteria that are found in the root zone of the prairies, they are nutrient magnets. They have biochemical means by which they grab onto phosphates, nitrates, potassium, all of these others. Here's the essence of the matter. In Iowa State, they found that a 50-foot strip of prairie grass next to a 200 to 500 acre row crop field captured 90% of the phosphates that were coming off of that field. Yes, they would get 6 feet tall, but they would have beautiful wildflowers for the honeybees, for the monarch butterflies, and so forth. But again, they would filter out, grab onto, stop, retain the sediments, the silt, the soil that's moving off, and the nutrients that eventually would end up in Lake Erie, but we'll stop them in our ditches. Our roadsides aesthetically would look gorgeous. We'd drive down the road, instead of just seeing a V-shaped green ditch, we would see patches of different colored wildflowers, waving grasses, different beautiful colored butterflies during the summertime and the winter. And in the wintertime, we don't mow those grasses down, they stay up. Those grasses become a living snow fence. So the snow is blowing across the field, stop in the ditch, get caught behind the grass, and it would make winter travel a little easier too.
Prairie grasses are amazing as I'm getting to know them more. The grasses are intense. They can capture the soils, keep them from eroding, and keep the waters moving down our streams into our Great Lakes clean.